Hey everybody, and welcome back to another installment of our series covering Singularity Container Services. We've covered a lot so far in this series, and this video is no exception. Today, we will be covering running our TensorFlow container that was created in the previous installments, CIF encryption, and browsing the Singularity Container Services Library. Let's jump right back in and start with running our TensorFlow container. We readied our WSL2 environment with Singularity and the relevant CUDA libraries in previous videos, so be sure that you are up to date before attempting to follow along with this demonstration. We'll start by using the Singularity run command to run the GPU-enabled version of TensorFlow from the Singularity Container Services Library. We will also use the nv and nvcli commands to check that TensorFlow can see our GPU. Since this is a large container, this process can take a minute, so we're going to speed past this. Now that Singularity has been launched, let's start with Python. From here, we'll first import the TensorFlow package, and then perform a device query to see the physical device GPU. As you can see here, we have gotten some warnings about NUMA support. This is a side effect of the WSL2 session, but it will not harm our ability to use TensorFlow, so you can ignore these warnings for now. Using information found in the TensorFlow Beginner Quick Start doc, we will create and train a model and load some data using the Keras model. You should receive an output similar to what you see here on the screen, with information about the GPU on the model line. In our case, it shows an NVIDIA GeForce GTX 950. Continue to prepare the model with the commands you see us using here, and once you're all set, you can run the training task. Success! You can see the training is successfully using our GPU via the CUDA Blaze library. Singularity containers for CUDA applications can now be developed, tested, and used on a Windows platform. All of the standard Singularity features work well under WSL2, and in future versions of Singularity CE and Singularity Pro, we are aiming to make the nvcli method of GPU setup the default, which would make this process even easier. For more information on training tasks, you can find the link to the TensorFlow Beginner doc that I mentioned earlier in the description below. Next, we're going to talk a little bit about encryption. As I'm sure you are aware, encryption is a well-known technology that is used to protect sensitive information. In our case, we would be using encryption to safeguard the contents of a container across a variety of cases. The Singularity client can locally build an encrypted container from the definition file using passphrase. This allows the root file system, or rootfs, within a container to be encrypted at rest, in transit, and even while using. To demonstrate this, we are going to build a container from a definition file that uses curl to call out to a console-oriented weather service, the link to which can be found in the description below. Launch the Nano editor and using the post and runscript commands to fill in the information and save that as our definition file. We're going to call it wttr.def. Now that we have that created, we will use that definition file to create our encrypted container. We are doing this using a simplified passphrase method, which we would like to note that we do not recommend for production purposes. For more information on why, check out the link for the Singularity encryption doc in the description below. Great, now we have an encrypted container. Let's use the Singularity CLI to take a closer look at the container that we just created. As you can see, our definition file was used during the build process in ID1, and ID4 denotes that the container is encrypted. Before we sign and push our container to the library, we are going to remove the definition file information using the Singularity CLI. This is because the definition file information will not be encrypted like the rest of the container. Now that that is removed, we can check the container contents again and see that ID1 is no longer there. So now we can move forward with signing the container. One more time, we'll take a look at the details of the container, and now we can see that ID1 has information about the SHA-256 signature. Now that our container is encrypted and signed, we can push this container into the repository. We will also add an eSign tag to indicate to others that this container has been both encrypted and signed. Now that our container has been pushed to the Singularity Container Services Library, we'll move to a new window to demonstrate what a pull and run operation of an encrypted container will look like. To do this, we'll be using the Debian app in WSL2 and change the background color of our command window to blue to differentiate this visually. However, we will not be covering how to set up the Debian app in this video. So if you would like to see those instructions, check the description for a link to documentation on this. Now, in Debian, if we run the Singularity Remote Status command, we will see that this environment is logged out and not using any authentication tokens. So we should be ready to pull the image from the library. Let's do that now. Using a quick siflist command, we can see that just like before, our container is encrypted and signed. Before trying to use this container, however, it would be best to verify where the container came from. We mentioned earlier in our video series that when the Singularity client is not the author of a container, the verify command can perform a remote verification of the container along with the author's email and fingerprint. We can see that attempting to run it displays an error message. This is because we do not have the passphrase to decrypt the image. So let's try running the container again, this time using the passphrase. This time it runs as expected and we get a weather report for our location. Last but not least, we're going to talk about browsing the library. The Singularity Container Services Library is the largest collection of CIF containers made for and by the community, and it can be browsed by using the search function on the web interface. Since we created a TensorFlow container for our example, let's start off by searching for other TensorFlow containers. You can see multiple containers, including the one we made in this series, in the search results. If you have been following along with this series, you may also remember that we created an Alpine container. So let's try and search for some other Alpine containers as well. Once again, our search results show us multiple containers that have been made by others and are willing to be shared, along with the My Alpine container that we made earlier in the series. Another popular container is called RStudio. Let's do a search for that and see what comes up. Just as before, we can see our search results show us multiple containers that have been made by others and have been pushed to the library. Finally, let's do one more search for a WTTR container. As our search results populate, we can see the container that we created, encrypted, and signed earlier in this video is included among the results. If we click on that container, we can see the lock icon next to the container name along with the signed icon and other metadata. We can also see an example pull command that can be used in the Singularity client. And with that, we have once again come to the end of another video and also the end of our series. We sincerely hope that you've enjoyed this series and that you learned a thing or two while watching. Feel free to sign up for our newsletter and follow us on Twitter @Sylabs.io and @Singularity_CE to stay up to date on the latest news and to make sure you don't miss out on any videos that we put out in the future. Don't forget to like this video and subscribe to our channel for more content like this, and feel free to leave a comment if you have any questions on what we've covered in this series or have any other ideas about what you'd like to see from us in the future. Thanks for watching!